Hey everyone, welcome to this explainer. I am super excited to jump right into today's material because, well, we're unlocking a literal superpower in programming. We are diving deep into Python function basics. Going through the material for this, it hit me, learning this concept is the exact moment a beginner stops just typing lines of code and actually starts architecting software. So, if you've been writing your scripts line by line, top to bottom, get ready for a total paradigm shift. We're going to look at how to build these magical, relentless little helpers that just never get tired of doing exactly what you tell them. Sounds pretty cool, right? Let's jump in.
Okay, to really wrap our heads around the core philosophy of what a function is, let's take a quick mental trip to your local pizza shop. Have you ever watched someone use one of those massive, traditional rocking cutters to slice up a huge pie? You might have noticed how, let's just say, uneven those slices can be, depending on who's doing the cutting. We've all experienced the absolute tragedy of reaching into the box and getting that tiny sliver that's basically just crust, right? Meanwhile, your friend casually grabs a slice that's half the pizza. But what if you were an engineer and decided to invent a machine to solve this exact problem? A machine that guarantees absolute perfection, every single time, without fail.
Imagine you build this magical contraction and call it the slice_pizza machine. You just feed a whole unsliced pizza, any size, into one end. That unsliced pizza, that's your input. Instantly, the machine hums to life, and out the other side comes a perfect, evenly sliced pizza. Bam, that's your output. The beauty of it is, you don't ever need to look inside the machine. You don't have to oil the internal gears or even remember how you assembled the blades every time you want to slice. You just hand it the input and trust it to give you the exact output. This right here is the whole essence of digital logic. And in Python, when you use a machine like this to produce an output, we call that invoking or calling the function.
So, moving from pizza mechanics over to actual Python, we arrive at our formal definition. A function is a set of reusable code designed to perform a specific task repeatedly. Now, the absolute most crucial word in that entire definition is reusable. Seriously, think about it conceptually. Without functions, if you had a complex calculation that took, say, 100 lines of code and you needed to run it 50 times in your program, you'd end up with 5,000 lines of messy, unreadable spaghetti code. No thanks. By encapsulating that task inside a function, you just build the machine once. From then on, you literally just call its name. Mastering function basics really gives you the foundational building blocks for creating scalable software.
All right, moving on to Section 1, Python's built-in functions. Let's see what's already prepackaged for us.
What I found really fascinating going through the source material is the realization that even if you are an absolute beginner and have barely touched Python, you're probably already using functions without even realizing it. Python actually comes right out of the box with an extensive library of pre-made, prepackaged, built-in functions. The original creators of Python knew that developers everywhere would need to execute certain core tasks constantly, so they just went ahead and wrote the complex underlying code for you. The whole philosophy here is simple: never reinvent the wheel if you don't have to. Let's look at the mechanics of two famous built-in functions you'll use all the time. First up is the print function. On the surface, it just displays messages on your screen. But under the hood, it is doing some heavy lifting. It's accessing your system's memory, grabbing values, and translating them into readable text. And get this, you can pass multiple items into it just by separating them with commas. Easy. Then we have the input function, which is honestly kind of mind-blowing when you really think about it. When you call input, it literally freezes time in your program's universe. It halts all execution and just patiently waits, refusing to move forward until the human user types something and hits enter. It's this highly complex interaction packed right into one tiny, perfectly built machine.
Which brings us to Section 2, defining your own function, where we start creating our custom machines.
Built-in functions are incredibly helpful, for sure, but the true power of programming unlocks when you learn to construct your own custom machines from scratch. Every single custom function begins with the keyword def, which is short for define. Right after def, you declare your function's name, followed by parentheses, which will eventually hold your parameters, and finally, a mandatory colon. Now, if you've coded in languages like C++ or JavaScript before, you know they rely heavily on those visually cluttered curly braces to group code. Well, Python just tosses that right out the window. That mandatory colon tells Python that everything indented directly beneath it is the body of your function. It is a brilliant, elegant design choice that forces your code to look visually clean and perfectly structured.
Let's walk through the logical flow of a custom function from our source text to really experience that aha moment in action. Imagine designing a function that processes numbers. First step, it asks the user for a number, instantly converting it to an integer. Next, it runs a math check using the modulo operator. that's the percentage sign, to see if the number is perfectly divisible by 2. Basically, if it is, it's even. Finally, it generates a random integer between 1 and 10 and adds it to the user's original input. The true magic of function basics here is realizing you can take these 3 completely distinct, somewhat complex actions, wrap them all up, and execute them perfectly with just a single, simple command anywhere else in your software.
Next up, Section 3, Parameters versus Arguments. Let's clear up exactly what the difference is.
Okay, so the concepts in this next section represent a distinction that absolutely separates beginners from true programming experts. People constantly use the words parameter and argument like they're the same thing, but they are entirely different concepts. Think of parameters as empty boxes with labels on them. They're just expected placeholders that you define during your initial function declaration. They just sit there, waiting to be filled. Arguments, on the other hand, are the actual presence you put inside those boxes. They are the real data values you pass into the function when you invoke it. So, your machine defines empty parameters when you design it, but you pass real arguments to it when you actually turn it on. Python then elegantly takes your arguments and maps them right into those parameter boxes.
Moving on to Section 4, Returning Results and Defaults. Let's see how our machines send those results back to us.
Once you've successfully passed your arguments into the machine and the internal gears do their work, how does the machine hand the final product back to you? Well, you use the return keyword. When Python encounters a return statement, it instantly hits the brakes. It stops executing the function entirely and sends that specific result directly back to the exact line of code that called it in the first place. And here's a really surprising fact from the source material that I found genuinely fascinating. All functions return results in Python, even if you don't explicitly tell them to. Yep, if you forget to write a return statement, Python kind of sneaks in behind the scenes and quietly returns the value none by default. It makes sure it never leaves you hanging.
Now, what if you want your custom machine to be virtually indestructible? Let's say you're coding a video game, and you have a function to spawn a player. If the system accidentally forgets to pass the argument for how many lives the player gets, you really don't want the entire game to crash. You solve this with default parameters. By defining something like b equals 1 in your initial setup, you're basically telling Python, hey, if the caller forgets to give me a value for b, don't panic, just assume it's 1. This guarantees your code just keeps running smoothly, making your software deeply resilient to any missing data.
And finally, Section 5, Documenting your functions using what are called doc strings.
Let's wrap up with a best practice that truly elevates you from a good coder to a great software engineer. There's this old saying in computer science that code is read 10 times more often than it's written. When you build these complex, magical helpers, it is absolutely imperative to leave a little manual explaining how they work. We do this using docstrings. A docstring is basically a specialized comment placed immediately under the function definition. It describes exactly what the machine does, what parameters it expects to receive, and what it promises to return. Seriously, docstrings aren't just a professional courtesy for your teammates, they are quite literally a love letter to your future self. They will save you hours of frustration when you open up a script 6 months from now and try to remember what on earth your custom machine actually does.
We have covered an incredible amount of ground today on our journey through Python function basics. We started by conceptualizing an automatic pizza slicer. We learned how to harness Python's pre-built tools and finally explored how to engineer, protect, and document our very own robust software machines. By mastering inputs, arguments, returns, and docstrings, you literally now hold the keys to writing highly efficient, scalable code. So now that you deeply understand how these reusable helpers operate, I want to leave you with a real-world challenge. Think about this. What repetitive, everyday task in your own life, whether it's sorting 1,000 unread emails, organizing your budget, or managing some massive spreadsheet, do you desperately wish you could build a custom Python function for? Take that reusable machine mindset we developed today. Open up your code editor and start architecting your own solutions. Thanks so much for joining me in this explainer, and happy coding!